61 attendees are there. Still, we'll wait a couple of minutes. Okay, whenever you log into your Moodle site, actually the course arrangement is in such a way that, say for example, we have CSE, then UG, and then semester number. Say for example, for your case, maybe it is 5th semester, right? And then we have divisions. Okay, but now what I did is I created a single course for both division A students, division B student. Can you access whatever the contents mentioned here? Because I guess I prepared this code under division A. So this is a question for students from division B. Can you see these contents? Please respond to the poll. I just fired one poll there. Especially I mentioned this for division B. Reason is maybe you are getting two courses there for operating system, but then the question is because I also enroll yourself in this course, you should be able to see, because maybe you are now getting two courses of operating system. What I'll do is I'll either hide the course from division B and you'll directly go with this also. Okay. 6 students are saying they are not able to see the course. I request you go to your dashboard and look for operating system without mention of the division. Okay, fine. So let us start our today's session. Even before starting this, the important thing is under this course, let me close everything first of all. Okay. There is unit number 2, that is the process management, and under this unit there is interactive content on multi-threading. So I request all the students to go through this. Now whatever, anyway, I am going to open this now for today's session also. Even last 2 sessions, whatever the presentation I selected from this interactive content only. Now I added few questions in this. So you are supposed to go with the question. So it is like a combination of let me open it. Let me open it. So for example, these are the interactive content on multi-threading, and this denotes the slides. So this is first, and whenever you see this circle, there is a question actually, and different types of questions I use, like multiple choice, maybe single answer correct, multiple answer correct. So most of the things are there. Okay. So for example, let me show you how it works. Is which of the following statement is false about the thread? It takes more time now because checkboxes are there. Definitely you can select multiple things, and whichever the answer you would like to select. Say for example, I select this one. Thread is a lightweight process. So actually this is not false statement. This is true statement. But now if I click on check, it says thread is lightweight -1 marks. Okay. So you again click on retry. Say for example, thread consumes less system resources and more time, or thread take less time for switching. Again, if I click on check, it says no. Again now if I select thread takes more time to terminate, and something like this, one more. Now this one is correct, but this is wrong. So until and unless you are not giving correct, you will get 0 marks. Okay. So for example, if I select here the correct answer, it takes more time to terminate. It takes more time to terminate, and now if I click on check, it says correct. You will get 1 star. Okay. Similarly, you are supposed to finish this, and at the end you will get the summary on like how many your first attempts are correct and how many are wrong. My suggestion is, before attempting this questions, try to read the slides, because the questions are based on those slides only. Okay, like which part is shared, something like this. Now I'll stop here, and now I want to go to the POSIX threads. Okay. Now yesterday we discussed this part. Now today I just want to write one program in C language. So I'll make use of C language here. The POSIX threads can be supported in C and C++ also, both languages. The thing is, I'll just select C language here. Okay. Before that, is there any doubt? Hello? Hello? Aditi, mute yourself. I'm getting echo. Okay. So, if you have any doubt regarding this, we'll definitely discuss. But to make the things clear, what we'll do is we'll write a program. So let me switch to my editor. So basically, the header file required is pthread.h, pthread underscore create. This is the TID, rather I can say, thread ID. Second one is thread attributes. We'll keep it 0. Next is we need one function which will be called whenever you create the thread, and that will automatically. The prototype for that function required is void star as a return type and void star as a parameter. Name, you can give any name. Next one is the arguments. So last parameter is regarding the arguments. So arguments required for that thread. Okay. So let us move to the editor, and let me go here. So my thread.c, Okay, so let us start writing the program. So this one, let me put the name like my thread.c is name of my file. So we need to start with the header file. So header file required. So as usual, because this is a C program, standard input output I'll include. And for threading, I need to include pthread.h. So step number one, rather I can say, is to include the header file pthread.h, and one instruction is compile this program with -lp thread option. I discussed this part yesterday. -lp thread. Link the pthread library with our program. So that is what LP thread option is. So for example, if you are using GCC, it should be GCC -lp thread and whatever name of my program is there. So here I use my thread.c. Okay. So again, if I go back to the slide part, fine. What we need is we need one function. Here we need one function. Now the program will try to solve is very simple. So for example, let us talk about that. Even before this, whatever I am typing in my editor, VS Code I am using, is it visible to you? Somebody can please respond. Is it visible? Fine, fine. So we need to have select one kind of assignment. Say for example, so what I'll select is, say for example, uh, we'll do some sort of a sum. Will we pass one number n and we'll calculate 1 plus 2 plus 3 plus up to n. Okay, so input is n, that is integer number, and output is sum up to that n. Okay, we will go with simple for loop. So for I is equal to 1, I is less than equal to n, and we'll go on adding all the steps. Okay, now this value of n will be passed by the main program to the thread function. That is the thing, and thread will access the global variable. So for example, let me declare one variable called as a sum, or you call it as a result, so it doesn't matter. So sum. So this is a global variable, and this global variable will be definitely shared. So will be shared between threads. Global variable, this will be shared between threads. Okay, so that is one thing. So that is the case, because thread, as I already mentioned, shares whatever the things provided to it. So for example, data part is already shared there. Okay, so I declared one variable called as a sum. Okay, now that is one thing. Next important thing what we need is we need to write a function, and that function will be called by the thread. So let me name that function as a runner. Okay, so we if we go back, see the kind of function we need is name of the function, and then its return type should be void star, and only one parameter it will take, and that is void star. Right. So what I will do is void star. Say runner is name of my function, because thread actually want to run that. So runner, or you give any summer, doesn't matter. So void star runner, that is the return type. Runner is name of the function, and we need to pass say parameter. Let me call it as a param. So this is the parameter for that. Okay, this is the declaration of function which will pass to thread. Meaning of that is thread will call this function whenever you create a thread. Any doubt till now? It's very simple. Okay. Now let us write one main function, so which is the main thread of execution on successful it returns 0. And now what I'll do in this is, now very first thing, I want to create a thread. And again, if I go back to my presentation, remember the data type is pthread_t. This is the data type available from pthread.h header file. So I utilize that pthread_t, and let me call it as a TID. So that is my thread identifier. Let me put comment that thread ID. This is a thread ID. Okay. And next step is, now I want to create a thread. And for creation of thread, as I already mentioned in the presentation, the name of function is pthread_create, and in parentheses, very first part that is required is thread identifier. And remember, we need pthread again. If I go back to my presentation, have a look here. pthread_t star. Meaning of this is we need address. That is a pointer, right? So ampersand TID, because we already declared that part above. Okay. Next part is, as I mentioned, the thread attributes. Right now we'll keep it 0. Okay. Next one is the some sort of function callable I mentioned. Okay. And that function we want to call. Remember, don't make use of opening and closing parentheses here, because if you do that, then meaning of that is call the function. But if I just say name of the function, it is the address of that runner function. And see, its return type must be void star, and it should take only one parameter of void star. This is the pointer of such a function. And last thing is what we want to pass to that function. So some sort of value we need to pass. Now we need to play some sort of trick here, and that trick is, say for example, what I'll do is I'll take one variable called as a value, and suppose I want to pass it. Example, as an example, let us consider I just want to pass value 8 there. Now remember, if I say val here, this is wrong. Why this is wrong? Because pthread_create's last parameter is pointer, void star pointer. And if you say just val, it becomes integer. So if I say ampersand val, this gives me int star. What we need to pass is void star. So typecast it. So this is the way. And because this is a single parameter, yes, I can do like this. If you want to pass multiple parameters to the same function, then definitely you need to have your own structure, take the address of that structure, convert it to void star, and that will be passed to the function. So this is how to create a thread. While creating thread, if this call is successful, automatically this function will start executing. Okay, that is how we can create, and you can say directly invoke also. Automatically thread will start. Now let us try to write the definition of runner function. So void star runner and void star parameter, and what we want to do in this is, first of all, we'll initialize sum is equal to 0, because I just want to use for loop in order to create like add 1 to n numbers. Okay. Now this n we want to pass is to this parameter. Okay. But the way this is the actual value, we took address of that, address is converted to void star. Exactly reverse thing we need to do here. so that we'll get the value of n. So for example, int n, let me put this part above this, int n, say let it be capital N, int n, and how to get value of this is very simple thing. I want to get it from param, that is the parameter I pass, but data type of param is void star, right? So we need to convert this value to int star, okay? And int star gives address. I'm not interested in address. What we want is value, so star even behind that. So here see, ampersand val, we converted value to address, and this star converts address to value. Here we passed as void star, here we again converted back to int star. That is the way. So here we got the value of n, right? And now sum I already mentioned. Let us take one more variable for looping purpose, say I, and then my simple loop for I is equal to, let me start with 1. 0 I don't want because adding 0 doesn't matter. So for I is equal to 1, I is less than and equal to n, I plus plus, and what we want inside this loop is sum plus equal to I. Or rather, to make it simple, sum is equal to sum plus I. So whatever the value of n I pass, for example here I am passing 8, what I expect is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay, so that is the value I expect. Anyway, there is a shortcut to do this kind of addition also, but let us go with this, right? And once you finish your task, just pthread underscore exit is used so that thread will be terminated. So here we created and invoke the thread. Here thread performs some sort of computation. This is the shared variable sum that we are modifying here, and here now I want to just display the value of sum. So printf, for example, sum is equal to %d. Let me put new line there and sum. Here problem may be, for example, let us see that. Let me save this code. Okay, and let me go to the command prompt and ls mythread.c, yes it is there, and now compile it. So gcc mythread.c, don't forget to link the POSIX thread library. So gcc -lp thread mythread.c. Yes, there is something wrong with pthread underscore exit. Yes, so what is that? Because if you go back to the presentation, pthread exit, you need to give some sort of a return value. Okay, so what I'll do is I just say, remember this is not the value written by the function, it is exit code for that. So let me put simply 0 there, and let me again compile it and execute it, and we are getting sum is equal to 0, which is wrong actually, which is wrong. The reason behind this is, see, we created thread, now thread is executing separately, thread, it is executing separately, and the main thread just tried to display the value of sum, which is 0. Meaning of that is still the thread has not completed. Okay, still thread has not completed. That means you need to wait for completion of thread, and for that the call is pthread underscore join. like in case of processes, we make use of wet or wet PID. Here it is joining a thread. And for joining a thread, two parameters. For which thread you want to wet, say for example TID, which we have created in earlier step, and what was the status? What was the status? So maybe I'm not interested in status, so I simply say null. That's it. Now this is blocking call. So the main thread will be blocked till thread completes the task. So whatever runner thread is there, okay, still that, so this will be blocked. So when this will complete, whenever this performs the complete operation, then and then only it is. So it is like it will wait for the thread exit. Once it exits from this, now we'll get the proper sum here. Let us save it. Let me open the terminal, compile the program, execute it, and we get 36. So 1 plus 2 plus 1 to 8, right? 1 to 8. So there is a simple formula. It is something like what is that? N into n plus 1 by 2. Okay, so 8 plus 9 divided by 2. So 9 into 4, 36. I guess this is correct answer for the value of 8, right? For example, if I pass the value of say 5, so 5 plus 4 plus 3 plus 2 plus 1. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10 plus 5, 15. What I expect is 15. So compile it and execute it. You'll definitely get the answer 15. Okay. Any doubts on this program or no? All the things we have used here: pthread create we use, pthread exit use, and pthread join we have used. This is the bare simplest rather I can say simplest code where we created single thread. Actually, two threads are there now, because by default main, if you don't create any thread, still one thread of control is always there. And then here with pthread underscore create, we have created one more additional thread. Okay, so two threads are there, right? Yes, if you have any doubt, please put your question in Q&A section. Even you can ask a question also. And if everything is fine, I'll move to the next slide. Okay, fine then. So what I'll do is let us move to the presentation. This is the POSIX threads. You can utilize it from C language and even C++ languages. Now let us move to the next, and these are the Python threads. So kind of how we can create multi-threaded applications. I don't know whether you have gone through Python or not, but still it is very simple. I explained this part yesterday also, but again see, the module used is threading. So threading is the module used by Python. Okay, that is number one. Number two, actually threading is a module in which there is one class called as a thread, and we are actually calling this is the constructor of that class. This is one of the constructors from that class, where the arguments are a kind of keyword based arguments. It's not positional arguments. Like keyword based arguments are supported in Python, where there is no need to mention in any specific order. You can directly just give name of the argument and is equal to provide value for that. That's so it is as simple as like that. So group, as I already mentioned, by default it is none. Right now it is not implemented. So that is for future extension. Target, this is the like callable. In case of previously we mentioned the function pointer. Okay, so target is the function pointer here. So this class again makes use of run method. So whenever you invoke start, it will invoke the run method, and that run method will perform this task mentioned by the target. Name, yes, as I mentioned, you can provide name to the thread, but by default it will try to construct name of this format: thread dash some number. Like for example, it will start numbering with 1, 2, 3, 4, 5, 6, 7, or something like that. Okay. Next one is arguments. Now, two ways of providing arguments. This is one where we can make use of tuple. So tuple is one of the basic things from Python, and dictionary is one more thing. So whenever you want to provide some sort of positional arguments, go with ARGS tuple. Whenever you want like keyword based arguments, then go with this dictionary. The dictionary provides key value pairs. This will create a thread, but thread will not be scheduled, or thread is not started automatically like what happens in POSIX threads. You need to explicitly start it with event.start. Okay, and then like join. So this is exactly same like previous slide. So we create a thread, we start execution, and then join. Join means what? Wait for the completion of this thread. So t1.join. Okay, that is how the POSIX, sorry, Python thread works. Okay, so let me go back. Let us see the same example for this. And now what I'll do is file my thread dot. Let me select the Python part. Now this is empty thing just for syntax highlighting, because this will highlight syntax for all the programming languages. So as usual, now name of this, now in Python hash is used for the comment. Okay, so name of my this file is say my thread.py. Yes, you can see there only my thread.py, that is extension. And here again we want to do the same thing. N is the input for this, and it is the thread will calculate rather 1 plus 2 plus 3 plus up to n. Okay, the same thing we want to do here. So like very first step, we need to import the threading module. So import threading, that is the first executable statement. So it's like try to compare it with my thread.c. Yes, file is open here also. So for example, here we are including pthread.h. Exactly same way we are importing the threading module. Okay. Then I need to have something like some variable. So this is like a global variable to hold the result. So maybe sum of 1 to n. Okay, and see every Python program there is one thing. For example, I can directly write code here, no doubt, but now by default if it tries to create some sort of a module, then in order to make it runnable directly from any script, we need to write one statement, something like when if name equals name. Okay, this is a way of writing. Uh, Only thing is this main should be in double quotes. Meaning of this is very simple. If this is the main module, it is like entry point for the execution, like the main function in C, C++, or public static void main in case of a Java, right? So exactly same thing. Here now, step number one, I want to create, and again important because there is no opening and closing, brackets, or rather I can say curly brackets. Okay, here indentation is based on number of spaces. So you should match the number of spaces. Okay, usually 2 or 4 spaces are used for that. Okay, so here I want to create a thread. Let me call it as a T1. No need to declare because this is dynamically typed. So whatever the data types are there, no need to declare variable. Automatically depending upon the right hand side, what is there in the right hand side, automatically the data type for variable will be selected. So T1 is equal to, say for example, threading dot. So this is the class. Again going back, I'm doing the same thing. T1 is equal to threading dot thread, and out of this, maybe I just want to make use of target. Okay, so rest of the thing I want to keep as it is. So for example, let me use target. Target is equal to, that means I need to again write some sort of method there. Okay, and I need to pass the arguments to it, and arguments can be passed with ARGS or KWARGS. I'll simply go with this one, ARGS. Okay. So arguments I want to pass is something like ARGS is equal to, as I mentioned, it is a tuple. You must use opening and closing. So let me select. I guess I 8. Let me give 8. Don't forget to give comma. Otherwise, this will not treat that as a tuple. Okay, that is some I can say syntactic sugar that you need to add to your content, right? So this is how we can create a thread. So T1 is equal to threading. Threading we have imported here, right? So T1 is equal to threading dot thread. Target is equal to runner. That means we need to define one function called as runner. So the way functions defined in Python is with keyword def. So def, you can see the syntax here. Def, name of the function, and whatever the parameter lists are there. So let me call it as a runner. So runner is the function to which I want to pass some sort of n, value of n. Okay, and again as usual there is nothing like opening and closing braces, curly braces. It is just by colon, right? So that is one thing. Now next important thing is what I want to do in this is something like for loop. So for, now whenever you want to have something like loop in Python, so for I in range, we can provide some sort of object range there, which will give you the value from 1 to that some value. And remember, it is, if I just say n, where n is equal to 5, so that will not be included. Okay, you can read that here. Range ij, it produces I plus 1, I plus 2 up to j minus 1. Meaning of that is this j is not included, but we want to include the n there. Okay, so maybe I'll use something like 1 comma n plus 1, something like this. Or even if you just say n plus 1, this is also okay. Fine. Colon. Now this is very simple loop. Same thing I want to do. Sum is equal to sum plus I That's it. That is the end of, and there is no need to use something like exit. Okay. So whenever it is finished, only thing is now, because this sum, it will create a new local variable, and if you want to refer the global variable, you need to use one more keyword called as global sum. Meaning of this is, here on line number 12, don't create new variable called as sum, rather directly refer the global sum. Got it? So we have function here, we have created thread here, I am passing value of 8 there, and next thing is we need to start the thread. So automatically it will call the run method of that thread class, and that is calling the runner method. Okay, so runner, anyway, you can give any name, doesn't matter. Now the thing is, now just we want to display the result of this, so go with print, and maybe sum is equal to, and I just want to say sum. But again, the problem here is it will display 0 as the global value 0 is there. Because we started it, we should wait for its completion, and for that the call is join. Let me save it, go back. So we created the thread, start the execution of thread, wait for its completion, and one method we have already written, which is called with the target keyword. The target is equal to run, something like this. Now what I'll do is, let us save it, open the terminal, ls my thread.py, yes, it is there, so I'm in the correct directory. How to execute is python and my thread.py, yes, you get sum is equal to 36, so which is the addition of 1 plus 2 plus 3 up to 8. Even we tested it for 5, yes, you can do that also, no problem. So save it, open the terminal, run it, you'll get 50. Fine. Any doubt in this? And that way, like we need to write minimum code here. So statement number 1, 2, small runner definition, and if you are making use of IPython, even this part is also not required. Line number 14, you can directly go with like something like this. But then whenever you are executing, when you say t1.start, okay, maybe it will be blocked. Whatever your interactive prompt is there, that will be blocked till the completion of the thread. That is the reason most of the time you should not write interactive applications. I mean to say, you should not use the interactive shell of IPython, right? You should write the program and then directly give complete file to the Python interpreter. Okay, so this is the how Python threads can be created. Next one is Java threads. Now I don't have that much exposure to Java programming language, but still this is a very basic thing. There are 2 ways in Java by which you can create thread. One way is making use of some sort of extend. So for example, first thing is extend, where you can extend the thread class. Right? So by default, java.lang, which is by default imported, I guess, right? So that has this thread class. So you need to extend the thread. That is number 1. But whenever you extend the thread, you need to override. Now I don't think I need to repeat what is overriding, method overriding, right? Overriding is what? Thread already has one method called as a run method, and its Signature is like void run only, no parameters. It returns nothing, no parameters are there. So you need to override this run method in your class if you extend the thread. So this is first method, and another way of doing so is by making use of runnable interface. Okay. So you need to implement the runnable interface. Again, whenever you implement runnable interface, there is run method. There is run method. Okay. So whenever, in case of Java programming, whenever you go with either extend thread or you go with the implementing runnable. Okay. So you need to create some sort of thread and you need to invoke the start method. So similarly, there is a start method, there is a join method. Okay. Only thing is, like in previous two examples, what I did is I utilized the global variable, and global variables are not supported in Java language. So definitely you need to create some other class which will hold whatever the parameters, whatever the result, and you need to provide some sort of additional methods for that. Okay, so let us go and try to write program for even Java also. So what I'll do is I'll write one new file, and let us write from scratch. Okay. As I mentioned, it is by default available in java.lang, so no need to like input anything here. So very first thing, and that is I guess I used wrong name there. Okay, fine, no problem. First of all, what I'll do is I'll write code something like the class my thread. Okay, and as I mentioned, two methods. Let us go with first one. That is where we want to extend the thread class. So class my thread extends thread. Okay, so that is one thing. Now, as I already mentioned, in this program also we want to do the same thing, addition of if n is given, what it will do is same thing, 1 plus 2 plus 3 plus up to n, inclusive of n. So that we need to pass as a parameter. Okay, so let us call that as a so private property of that class, so something like private intn. Okay, and whatever the sum, because we cannot have the global variables, let me have something like private int sum. Okay, and now let me add one constructor to this. So name of my class is my thread. So name of constructor should be again my thread, wherein I need to pass the value of n, and I'll initialize sum to 0 and n is equal to n, something like this. Okay, that is the way how we can pass some sort of values to it. And because we have extended thread, the overriding this run method is now mandatory. So let us try to override that run method. I already mentioned I want to make it public, and it is void, no parameters are there, so public void run. Fine. And logic of this is again the same thing. So what I'll do is for int I is equal to 1, I is less than equal to, I mentioned n, no, so n and I plus plus. And what I want to do inside this is sum is equal to sum plus the value of I. It's the same logic of calculating the summation. That's it. Okay. So this is my class. Fine. Now I want to test this class if it is working properly or not. Again, if you can see here, the problem is how I'll get the result, because result is stored in the private property of the class, right? So maybe I need to write one more method called as a public get result or get sum. Let me call it as a get sum. Public int should be public int get sum, and here I want to just return the value of sum. That's it. This is the class. Now no semicolon is required, because I think that is required in C++. Java don't needs that. And now I want to write a driver program for this one. So let me call it as a test method. Okay. So let me make it as a public. So public class test method, public class test method. Okay, because here I just want to do testing of whatever class I written for the multi-threading. And the entry point, as I already mentioned, public static void main, and string arguments are there. This is the standard template for any say driver program kind of a thing. Okay. Now I need to create object of my class. So my class is my thread here. So my thread, for example, as usual, I use T1, and now I want to create object with new, and say for example I want to pass the value of 8 there. So while this new my thread will invoke this constructor, value of 8 I pass, that will be assigned to this gen, and whenever I start this thread, it will actually call the run method, which will do addition of 1 to n, and addition will be assigned to this variable sum, and whenever at the end I'll call this get sum, I'll get the result. That is the I can say test case for my public class testing method. Okay, so this is I simply created it. Now say simply so t1 dot start method I need to call. This will invoke the run method, and now I just want to display sum. So system dot out dot println, and I'll directly get the sum. Get sum, yes, that is the name of method. That's it. But again, as I mentioned, you need to wait for completion of that thread with t1.join. Now, only problem here is because Java makes use of exception handling. Now, the exceptions must be whatever this t1.join. So I need to put the all stuff in try and catch. So try something like this, and anyways you can do it individually for also just for t1.join, but let me put everything. So try catch all the exceptions. So let me put as exception e, and don't do anything. Okay, so this is for a try, this is for public static void main, and this is now the problem is name of my public class is test my thread, so I should save this file as test my thread.java. Okay, so what I'll do, let me go to the file and click on save as and test my thread.java. Okay, so I simply saved it. So what I'll do is now let us move to the terminal and check test my thread.java. Yes, it is there. Now compile the code, test my thread.java. Yes, everything is fine, and now execute it. test my thread. I passed 8, so I expected 36. So this is multi-threading in case of a Java programming language. Just we need to write additional class. Reason behind that is we cannot have global variables in Java. Okay, so that is the case. Fine. So these are all Java threads. Okay, and just last slide I want. Now these are the questions on all this stuff. The last slide I want to talk about is thread pools or process pools. Okay, maybe just 1 or 2 minutes are required, and that will be end of this multi-threading. So from unit 2, what is remaining is just the scheduling part. Now let us try to understand the concept of thread pools or process pools. Thread pools are supported by majority of the programming languages, including even C, C++, Java, Python, all. Okay. Now let me tell you what is this. Before starting with pool of threads or processes, what is we studied already is the concurrent servers, iterative servers and concurrent servers. Now consider the example of a web server, concurrent web server. Okay. Now how concurrency is achieved is whenever there is a request from the client, if request is received, we create a separate thread or separate process. Now because our topic is threading, let me call it as a thread, no problem. But the same thing is true for processes also. So separate thread will be created or separate process will be created, and that thread will handle that request. I guess it is already I mentioned in the motivation part, this one, multi-threaded server architecture. So whenever there is request from the client, it creates a new thread, and this thread provide, or this thread rather say provide the service to the client. And the original thread, the main thread, will be listening for new requests. Here my question is, if there are 1000 requests, can we create 1000 threads? If your hardware supports that, yes, we can create, no doubt. What about 10,000? Can we support 10,000? Okay. What about 20,000? 20,000 simultaneously clients are coming there. So this definitely creates a problem, and the problem is if we do not have sufficient resources, maybe our web server will be crashed. Okay. So there is drawback of iterative web servers, because only one thread or only one process is handling all the clients. So client will not get quick response. So we move to concurrent servers. And the drawback with concurrent server is if number of clients are too much, maybe our server will crash because we do not have sufficient resources there. Okay, that is the reason the concept called as thread pools or process pools is used. Okay, so traditionally we have, like, for each and every request we need to create a thread that will provide some sort of service. Once that is done, destroy. Remember, when request comes, then we create it. So what is the time required to create and destroy? Right? We need, say for example, if client request is coming and then I created a thread, definitely creation of thread needs some time. Till that time, the client has to wait. That is the question. As I already mentioned, what is the upper limit? How many threads you will create? How many processes you will create? Solution to that is thread pools, where pre-created pool of threads or processes is there. For example, how it works is very, very simple. So for example, for my web server, suppose I want to handle 100 clients simultaneously. Still I can say it is concurrent. Now here we want to take advantage of both iterative servers also and concurrent server also. Okay, so when I start my web server, I create a pool of 100 threads. Okay, whenever request is coming, I'll assign one of the thread from my pool. next request, next thread in the pool, next request, next thread in the pool, something like that. So if it is equal to 100, now all threads in pool are busy, for example. So for 101st request, that request has to wait. So there working is something like iterative. Okay, but whenever any of the pool from thread gets free, now we'll simply take. So all the requests will be in the task queue. Okay, web server will take up the task. It will assign to a thread which is free. Whenever task is completed, so you assume this as a free. This is a free thread from my pool. So it is something like up to, just I mentioned example, up to 100 requests, it is concurrent. After that, it is iterative. But definitely, because I know the capacity of my hardware, my web server won't be crashed. If you add additional hardware, you can increase that number of threads or number of processes in the pool. Okay. 2-3 advantages. Number one, as I mentioned, our web server will not crash. Number two, we are not waiting to create the thread till client request is coming. It is already there. So whenever request is coming, directly assign that request to the thread. So it will provide quick response to the client. Secondly, no need to destroy it because we want to use or we want to utilize the same thread for other requests also. So creation time and destroy time at runtime it is saved. Okay. So that is the concept of pool of threads or pool of processes. So that is end of multi-threading part. So if you have any doubt, any question, put it in Q&A section. And I request everyone to log into your Moodle and complete this activity. Okay. So once you log in there, you go to the unit number 2, process management. There is interactive content, and read the content carefully, answer the questions carefully because there are grades assigned to it. Anyways, you are getting answers. I'm not saying you won't get answer. Even though you give wrong thing, it will tell you it is wrong. So there is chance for retrying it, no doubt. But even after what happens is your first attempt that will be counted. Okay. I guess 102 participants were there, but by this time there are just 79. Okay. So I request you to give poll of attendance. Just a minute, I'll put the question there. What I'll do is create a question. Your attendance, let me mark it as a present and absent. Just immediately respond to this. Still 11 students are there. 10 are remaining. That's it. Okay, thank you.